with Daryl and Jesse to hopefully enjoy
nominal trajectories.
What I would expect to be a beautiful, very noisy nominal landing of that booster. Daryl, how was launch? How did it look out there? All right, we're going to hang off. They're not quite ready yet. I'm sure they're just enjoying it. They probably got up to watch that launch, and they're probably getting positioned again. So I don't blame them.
Me neither. Yeah, they should definitely soak it in.
So that second stage Merlin vacuum engine, MVAC as we like to call it, that produces around 210,000 pounds of thrust once it's on orbit in the vacuum of space.
On entry burn has started.
All right, so call for the entry burn there. I think Daryl and Marina are ready for us. They should be there with Jesse to talk us through the landing. How was launch?
Oh my goodness!
It's incredible.
It was incredible.
That's why we're late. We're all talking at the same time. It's great. Can you tell that we were excited? We were standing there. We saw it. It was so clear we could see the separation as it was going the entire time. Jesse, I mean, isn't that
awe-inspiring?
Mind is blown.
So it's going to be landing right behind us, and we've got a view now of the actual booster coming back. It's got its grid fins out. And that's helpful. It has to use those things.
Yep, it has to help steer it as it's making its way back to land. So it's the steering mechanism.
It's really interesting that it lands right next to the launch pad. We have a little tent over top of us, so we're not going to see that first boost back. But we have a clear shot of it coming down onto the pad. The other thing we're waiting for, and we're making sure that we keep track of, is the engine cutoff of stage 2, and we're going to call that out. Here it comes. There it is.
Wow. Oh my goodness.
Coming in at an angle and just straightening out. What do you think, Jesse? That's amazing.
Oh my goodness, I might cry right now.
This is so incredible. Every time I see this, it's just
slowing down so perfectly.
Perfect.
Just hovering. There's the sonic booms we talked about, and touchdown.
Oh my! We heard that.
Oh, that was
and Falcon landed at LZ4, landing operator
beautiful.
Into 11.100 on recovery 2.
I'm a little teary-eyed right now.
Echo of the power to see it here in person, to feel it.
Oh, and like Jesse said, no matter if you see it or not, you always hear it, right? So that sonic boom is recognizable wherever you are.
Reverberating through the valley here.
I know.
Well, what'd you think, Jesse?
Oh, I have no words. That was incredible. Like, as many launches as I've seen, seeing it in person is a whole different experience.
The crowd that's with us, you can hear them cheering and everything. They're just totally like, so in awe. We're so glad that we could do this and have you join us with this. Jesse Anderson from SpaceX, lead manufacturing engineer. Thanks so much for coming out here. What a moment.
So much for having me. This has been amazing. Thank you.
Absolutely.
Thank you.
All right. Well, the coast phase is about 45 minutes away, and so we don't expect any activity to report at this time. But if there is, we will let you know. And in the meantime, we'd like to tell you about the science behind the Sentinel-6 Michael Freilich mission. And we're going to get to that in a moment, but we have a moment here where we're going to sync up and simulcast with our partners from the European Space Agency. And when we do that, that's going to allow both channels, both ESA and NASA, to carry the same broadcast at the same time. I'm going to talk a lot about science, and we're going to get to that in a moment. But first of all, I want to get your reaction to watching both the launch and the landing.
It's spectacular, Daryl. I mean, it's so beautiful when everything comes, and like Jesse was saying, a well choreographed ballet. It's the best choreographed ballet in the world, and it did everything that it was supposed to. The launch was beautiful. I'm so glad the winds quieted down when they were supposed to, so that we could get that rocket launched, because this is incredible science that we're going to get from Sentinel-6, and I just can't wait.
Well said indeed. Okay, now we are going to turn it over to our friends from ESA. Let's join moderator Louise Houghton from the European Space Agency.
Sentinel-6 really would like to thank NASA and our friends in the US, also NOAA, for this contribution they have made. Incredible. They have been an excellent partner. They have been very reliable, and they really have delivered their part on time and in very significant terms. The launcher we have just seen, but also very important instruments like the microradiometer and several other components. And this is a model cooperation I would really like with Thomas and his team in the US discuss further cooperation opportunities, because this is just so wonderful what we have done with Sentinel-6 Michael Freilich, and there is much more to come. I have quite a few ideas. I don't want to go into depth right here, but I think this is so successful that I would like to expand that.
Well, thank you so much, Josef. I think you're saying there that international partnerships are so important for these space missions moving forward. And we've, of course, been able to monitor the oceans from space for nearly 30 years now. And before we continue this conversation, I want to take a look at a video which will show our achievements to date.
Great.
Sorry, this is a little...
You're coming back to me, or?
Yeah, we are.
What would you like to ask me, so I can gather my thoughts?
It's okay.
Nadia?
What difference is Sentinel-6 making to revolutionizing oceanography?
Okay.
Still have 10 minutes. You've got time. We've got plenty of time. You'll be out after the video. You'll have like six minutes.
I don't hear the video. I don't hear the video.
She's missing.
She doesn't have a feed.
Give me a cue.
Count you down.
The altimeter was actually an experiment on board Skylab, which was 50 years ago now. I mean, the way that this technology has transformed over this last half a century is quite fantastic, isn't it, Thomas?
Oh, it's amazing. I mean, for me, when you just think about it, you know, you have this spacecraft up there at, 1,300 kilometers, going at 8 kilometers per second, and you're locating it within a centimeter or so, exactly with all these, with the altimeter, but also the GPS receivers and the supporting instrumentation. For me, it's mind-boggling, and of course, it's so important because it affects our lives in a direct fashion every day, even if we don't notice that.
What challenges do you think that we're going to come across in the future with working with this international partnership?
So look, I believe that for the first couple decades, the question really was, are the ocean levels rising? The question to that is absolutely yes. Now, the question that we're dealing with, and as an international community, is how are we handling these rising oceans, and how do we make sure we don't go to levels that we don't need to? And so for us, kind of the local impacts of those around the world, whether it's in Europe, whether it's in the United States, and everywhere else, are what's going to drive our research, and therefore the high resolution that this spacecraft provides us is absolutely critical. So that's the questions the international community has to come together to deal with these problems, because each one of those assets, serves all of us.
Well, we have been hearing more and more about how oceanography has been revolutionized by satellite observation. So Nadia, maybe you can tell us a little bit more about why Sentinel-6 is making such a difference in that development.
Yes, Sentinel-6 is indeed building on a very rich heritage of JSON-class altimeters, and what we expect to see a new science coming out of Sentinel-6, that it would open up new frequencies and give us a fuller picture of what do we know about the oceans. And Ocean altimetry by now, it's a mainstream tool of modern physical oceanography. So if you're a modern oceanographer, at one point of your life, you clearly looked with this data. Either you're studying tides or sea level, ocean circulation, or winds or hurricane prediction. You were exposed to this data, and we expect from Sentinel-6 to continue doing this discovery on a higher resolution and longer time scales.
Well, if Craig can hear us over in Europe, maybe I can come to you as well, Craig, and ask you your opinion on how this technology is really changing how we monitor the oceans.
To precision, which is essential because the annual changes are just a few millimeters a year. It's really remarkable. But you know, it can do a lot more. And recent work shows that the oceans are taking up much more carbon dioxide from the atmosphere